the video. So we've got our points laid out here, and we know certain things. We know that this is 2 pi. It's also 0, right? 360, right? If we were doing it in degrees, that would be 360 all the way around. But it's also 0. And we can do this. Like we could go pi over 6. We could go pi over 4. Think about this. This is my 45. This is my 30. This would be 60, 90, right? If this one would be 2 pi, right? Over 6, which would be pi over 3. And I can fill in all of these blanks, and I just want to fill them up to the 90-degree area, that right angle right now. This one is pi over 2. Each of these have like an XY coordinate. Think about this. These points, this 1, 0, means that we're coming over 1, and we've got a Y value of 0, right? We don't have an up and down. It's just a point on the axis. Well, each of these also have a point on the axis. If I were to drop this down to the line, right, this would be distinctly halfway between 0 and 1. This point would lie halfway between 0 and 1. At least let's hope so. And I would have a point here that is 1/2. And this point right here, my Y value would be radical 3 over 2. And I can prove these to you later. There's no reason for me to prove them to you now. I will prove them to you later and show you how they work. But honestly, it's just the distance that they go. Our 45-degree angle would be radical 2 over 2, radical 2 over 2. And our 30-degree angle is the same as the 61, but they flip position, right? So before, where it was 1/2 radical 3 over 2, this one is radical 3 over 2, 1/2. And these points I'm giving you will come into play more, and you'll understand them better as we move along. What I really want you to understand, though, is how they work from side to side. When we're talking about any kind of a graph, this quadrant, everything is positive. Your X is always positive, your Y is always positive. In this quadrant, your X is negative and your Y is positive. In this quadrant, everything is negative, right? And in this quadrant, you've got a positive X and a negative Y, right? No matter what your points are, that's always going to be true depending on that quadrant. If you're in this upper quadrant right here, our quadrant 2, that's what we call this one's quadrant 2. This one's quadrant 1, quadrant 3. They always do quadrants in Roman numerals, so, and quadrant 4. So no matter what, every point in quadrant 3 is going to be negative, X or Y. Doesn't make any difference, right? So if we wanted to fill in the values of all of these, if I were to take this graph and I were to fold it on the Y-axis, all of these points would match up on the other side. So if I folded it on the Y-axis, this would be 1/2 radical 3 over 2. This would be radical 2 over 2, radical 2 over 2. This would be radical 3 over 2, 1/2. The only difference would be is that all of these X values would be negative, right? So if I folded them over, the only difference between those values would be those are positive and those are negative. If I took this whole unit circle and I folded it over the Y-axis instead, same thing's going to happen. The things that lined up at the top are now going to line up at the bottom. So I'm going to do it in a different color so that you can kind of see what's going on there. I'm going to go with red. So technically this point right here would be this point, right? Because if I folded it on the y-axis, that's where it would land. So this would be our 1/2 radical 3 over 2. This would be, notice these are always, our 45s are always radical 2 over 2 for both the x and the y. And then this would be radical 3 over 2, 1/2. The difference is because everything in quadrant 3 is negative, this would be negative, this would be negative, this would be negative, 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 negative. Make some sense? Same thing though with quadrant 4. Quadrant 4 is going to flip over onto quadrant 1, right? And so we would know this is going to be radical 3 over 2. Ooh, that is just some terrible handwriting. Radical 3 over 2, 1/2. Radical 2 over 2, radical 2 over 2, and then 1/2 rad 3 over 2. And the only difference this time is that all our y's would be negative. So I just kind of wanted you to see how all of these points line up for you. I think that I'm not even going to make you fill one of these out yet. I think what I'm going to do is post a completed unit circle in all of the pieces. We weren't moving enough, our lights went out. So that you guys can see it. Like I said, I'm not assigning you anything with this. I just really wanted to give you guys a kind of a quick, not so quick concept of how the unit circle is put together and how these pieces fit. And remember that these are X, Y values, right? And they really come into play because things like the sign of some value, T, whatever, doesn't matter, is always going to be your Y value. Cosine is going to be your X value. Tangent is sine over cosine, so it's Y over X. And so that's why this stuff becomes so important, because it puts values to these things that it's hard for you to kind of wrap your brain around. It gives it a numerical sequence of values, right? So if I said, what is sine of t or sine of pi over 6, we could just come over here, whoops, to pi over 6, and we go, oh, it's 1/2. It's the y value at pi over 6. Does that make some sense? All right. Well, that is all I'm giving you guys for today. I feel like it was a lot of information, but luckily no work involved with that information, right? You guys don't have any homework to do. Fun part is tomorrow I will be doing this like live in class.